There we go. My key ready to go here. Manage at our local daycare. Build a rectangular playground with 3 sections in order to split children's by age. It's built next to the daycare to save on materials. If she has 750 feet of fencing available, right? Assume that that's how much is available, so that's important. When you do these ones next to a building, okay, pay close attention. Some might ask, where should I have the daycare? Always have it on one of the long sides. Okay, so you can have the daycare right here. So that means that on this side, and I probably said that on the video if you watched the lesson, I'm not sure, but it's always here or here. Okay, place structure, right? Place along the length. Okay, and so because you're kind of making the widths touch that one. So we have 1, 2, 3, 4 widths and just 1 length worth of fencing that we need. So we're saving a whole length for this. And I wish we could have this more dynamic, right? You'll be able to make it probably longer or further away from the daycare because you have that extra fencing available. You can bring this further out, right? Because imagine you used to have to cover this, now you don't. You have more fencing available for all the other sides. Okay, so that's we're not done yet. So basically 750 feet needs to be distributed amongst the length and 4 widths. And I will say this, width is already assigned, right? Values are assigned. So we want to isolate for length. So I'll say that length is equal to, you know what? I need to be careful because sometimes your brains need to follow what I'm doing. I'll say length stays here, and on the other side we have 750 minus 4W. In this case, you don't need to divide because length it doesn't have a coefficient greater than 1 in front of it. So, and I told you isolate L, right? I did tell you that, so it's not like this is a surprise. So that's 1 mark if you have that correctly. And then now we're going to figure out our lengths based on this. Okay, so for the first one, it will be 750 minus 4 times 100. Right? So that's 400, so this will be 350. Then it's 750 minus 4 times 120. And that gives you 270. And then the last one is 750 minus 4 times 150. And that would be 150. There you go. I want to make a note here. Notice that the values that I picked are not consistently going up by a constant. Do you notice that? It's 100, 120, so we're going up by 20 and we're going up by 30. Because of that, you also won't see a pattern here. If I had gone up consistently by 50, let's say, you should see a pattern here as well, okay? In this case, I didn't. I did that on purpose because it's not, you can literally pick whatever you want for W, okay? You get this? You could have picked anything you wanted for W. You and I should get the same equation at the end of the day. I just do this to make it easier for marking purposes, okay? So area, this times this, I'm just gonna write it like this. You don't have to, as long as your equation is correct, we're in business, right? So that's also 1 mark for the table filled out correctly. Don't mark it wrong, well, it should be the exact same values. Actually, never mind, because I already assigned values here. But if you made a mistake for your L here, then these values will be different. I wouldn't take marks off here. I would only take a full mark off here, okay? Determine the equation. relating the length and the area. So read carefully. So that means that this goes into L1, this goes into L2. And then we go stat, calc, quad reg. Okay. So first we're going to clear 350, 270, 150. Okay, good. 350 times 100, 270 times 120, and 150 times 150. There we go, 22,500. So now we're going to go ahead and perform our regression. There we go. So that's the equation we should all be getting, ideally. Right? So don't forget the x variable. Some of you were forgetting that. Okay, so you gotta make sure you have that there to get full marks. The province does take away half a mark for missing a y equals. Like if you do y equals, that's half off, or if you forget one of the variables. Okay, so be careful. Determine the greatest area that can be enclosed. This calls for second trace max, right? You're gonna find that at the vertex, and in this case it's a max. We know that because this is pointing down, right? This is pointing down, so that's where you're gonna get the greatest area possible, right? At the vertex. So let's graph this thing. I don't know if you already did. Even if you didn't, I'd still encourage you to do that. Couple things. I'm gonna have plot 1 on because it's a regression. I'm gonna just try to graph it, see if it works. Hey, it just happened to work because whatever I did before. So I will just increase my Y max a little bit. If you want to look at my window, you know what? I'm going to purposely get it all. I'm going to mess it up, okay? I'm going to have zoom standard. Don't see a thing. Well, just the blue line going here. I'm going to try zoom stat. That gets me started. And then I'm going to go window. Make sure the X min is like -5 or -10. Make sure my Y min is also -5 or -10. I'm going to try it again. Okay, so now I see the X and Y axis here, and I know where it's going. So I just have to increase my X max at that point. So I'm going to go 800. There we go. That's a pretty good parabola. Okay, so don't just stick with that little window. Some students think that's it. No, you got to be able to see the whole curve in quadrant 1 because this is there's a context around it. We cannot have negative length or width. We cannot have negative area, so we are constrained or restricted to quadrant 1. Okay, so let's go and find the vertex. I feel like most of you already did this one, but I'm talking about little things that could come up down the road. Okay, so here we go. Write this down. 375. This rounds to 35,156.25. Okay, so the maximum area, you're not done yet, right? The maximum area, right? Max area or greatest. What happened there? Maximum area is 35,156.25, and we are in feet. So you slap on the square feet there. Now you're good. Now you get a full marks there. Next, we're done there. I could have asked you what are the dimensions for this. Well, we know that the length is 375, and we can use the other formula to come up with the width. But this is it. Okay. Next, solve the quadratic equations using the quadratic formula. So when I say that, you have to use that one. Okay. So we need to first clean this up. So I'm going to go 3x squared. The negative 6x squared comes over adding. The negative 8x comes over adding as well. The 12 comes over subtracting. Okay, every single sign changes when you bring a term over. That's equal to 0. Combine like terms. 9x squared plus 8x. Oh, I forgot something, right? You see that? 4x, what's up, what's happening? So what I'm going to do is to fix this, I'm just going to say, hey, remember the 4x is still there. That's equal to 0. So don't forget about that one. So this one mixes with that one. That's 12x. Okay. And then we've got negative 12 trailing like that, equals to 0. I feel like this one was on the quiz. Something reminds me of. But anyway, so A is 9, B is 12, C is negative 12. Okay, so that's important. So now we go ahead and plug in. It's negative B plus or minus B squared minus 4 times A times C. All of that, the whole thing divided by 2 times A. And let's clean this up. Negative 12 plus or minus. We get inside the root, we get 576 if you plug this in. I encourage you to try that. Make sure you get 576 because that's, for some reason, I'm not always sure why you get a different answer in there.
If there's something that seems like, if you add like 2x plus this x, would it be just 2x or 3x?
3x. Yeah. Combine your like terms. Yeah. Yeah. You get the 576, right? You're able to get the 576? All right. Here we go. Negative 12 plus 576 over 18. We'll get an answer there. I get, when I do the adding, I get 0.67. Okay. When I subtract, I think basically this all comes down to, are you making sure you don't drop a negative somewhere? If you drop a negative somewhere, it throws you off big time. And so this gives you negative 2. How could you double check if you did this right? The best way, and I'm doing this because it allows me to review the other methods of solving. We're always finding the roots, guys, right? Roots, x-intercepts, solutions, they all mean the same thing. So let's do this here together. To check, I'm going to go to y equals. I'm going to clear everything that's there. I'm going to turn off plot 1 because I'm not performing a regression. Type the left-hand side into your y1. And then type the right-hand side into y2. It doesn't take long, and you can know for sure you did this right. Okay, so you type left-hand side, right-hand side, y1, y2. Double check if you did this right. Yeah, we're good. So now I'm going to hit graph. Not really good. Not really good. So I'm going to try, what should we try here? Which zoom should I try here? Zoom stat is out of the question. Zoom fit? Yeah. Throw a fit. If it doesn't work, just throw a fit. Okay, zoom fit. 0, right? If you press 0, you get that. Let's see here. It's all right, but it's not great. The greatest. I want to see here. Okay, but remember, we're looking at 0.67, negative 2, something like that. So I'm going to try something here. Second trace 5 and for intersect. And I'm just going to hit enter. Enter, enter, enter. It found the 0.67, right? The first one. And the other one is going to be a little further to the left, the negative 2. Watch this. You don't worry about the y when you do this method. It's always 0. It's always the roots. So I'm going to go to my window. I'm going to just, it's actually not bad, but I don't need so much on the X max side. I'm just going to go 5 on X max. Hit graph. And it looks like 2 straight lines because I'm really zooming into that. But I'm going to go second trace 5 here. And I'm just going to go further to the left because I know I'm looking at a -2. So I'm just going to go hit enter, 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 and there it is, -2, 4, which is what we were after, right? We're after this -2. So sometimes if you want to use it, it's up to you. It's there. But then you check and make sure you got these right, because then you get full marks, right? Next, given the following quadratic equation, determine what form is this in? It has brackets and a square. It's vertex form. Yeah. It gives us the vertex right away. I will probably ask you, I will almost force you to show me you understand that that's the case. How I'm going to do that, let me worry about that. You just have to know how to do it. So for example, if this is the vertex form, you should know, oh, it's taking the 2, changing the sign, and the k value here stays the same. Okay? I'm going to put an arrow there. Change sign, and I will highlight as well. Okay. This 2 here now turned into a negative. Okay. This -3 stays the same. That's how easy it is. You could use your calculator to absolutely make sure you got this right, but you don't have to. Okay. Vertex form is like this. This is the form, right, where this is h and this is k. Like the vertex is -h k, and this negative, what it does is it changes the sign that you have in here. Okay, that's the job of that negative. The only job is to change the sign of what is in there originally. So if you wanted to put a plus here, there's nothing wrong with it. If this is plus, the negative is going to turn that into a negative. If that's negative, this negative is going to turn that into a positive. Okay. Next, the number of x-intercepts. Explain how you know. Look at A and K. That's what you're looking at. A is equal to -3.5. K is equal to -3. Since they have the same sign, okay, since their sign is the same, there will be no x-intercepts. Okay. We know this, and I think you should be able to also visualize this. If you have a -k value, if this is your coordinate plane, you know that the vertex is going to be somewhere in here. It's going to be somewhere in here at the -3y level. And A being negative will make this point down. Okay, so it's somewhere in here. We don't know well, we actually know exactly, but it doesn't matter. K just tells us it's below the x-axis. And A tells us, hey, it's pointing down. So this will never, ever cross the x-axis. So no x-intercepts. Let's keep going. So what are we at on this page? Marks wise, 1, 2, and 3 is 5, 6, 7, 8, 9. So this page is worth 9 marks. See, I read your minds. A lot of you was like, I didn't know there was a backside. It says it right here. Continue. Next time would be like flip over, right? Or just like a hand waving. It's like, hey, there's another side. Just flip me over. It's not funny. Okay. Solve the following quadratic equation by graphing. Indicate keystrokes. How do you want to do it? By graphing, you've got two options. You can do y1 equals to the left-hand side, y2 is equal to the right-hand side, if you want to do it that way, or rewrite. That's first step, and then find x-intercepts. This one would be do that and then find intersection. Intersection or intersections. And I just used up all my space, but that's okay. So you choose how you want to do it. Maybe I will first, I'm thinking here, what's better? Let's do I'm going to put this into y1. I'm going to put that one into y2. And then I'm going to say second, trace, intersect. Let's do that. Can you take a moment to do that as well? I don't know what method you chose, but let's all try this one. And I'll let you struggle with it a little bit. See what you get. If you can even find the window. I'll just do my attendance. Okay. Anyways. Good thing you guys were in class, right? Anyways, sorry about that. So for domain and range, how would you do that? Well, domain is are my x values. I start at time 0, and this story stops in terms of time when time gets to 2.1. Okay. My range, what's the lowest height you ever get to, is 0, right? 0 is the lowest height. And the highest is 41.25. Okay, I would say time, and this is height above water. If you want the other notation, you would go 0, x, 0. Make sure if I give you a variable that you use that one. And squiggly brackets. Province is very picky with that. It's a context, so there should be no infinities, okay? Use the quadratic formula to solve question 4. You know what? I already did the work of rewriting it, so I might as well do it. So A is equal to -3, B is equal to 8, C is equal to 3. And here we go. X is equal to -b plus or minus b squared minus 4 times -3 times 3. All of that divided by 2 times -3. You got to be careful. When they're negatives, folks, I put them in brackets. For example, the 8, if that had been negative, I would have gone minus -8, so that you can see that there will be a double negative turning into a positive. Same with your 8 in here. A -8 squared is positive always. If you don't put the brackets down, your calculator will not think that the negative is supposed to be squared. It will just square the 8, not the negative. So you got to make sure you put things that are negative in brackets. Okay? That's -8 plus or minus. What is that? 64. 64 here, right? Minus 4 times -3 times 3. That's 100, which we all know is 10, right? Square root of 100. And at the bottom you have -6. So here you have your two answers coming up. x1 would be negative 8 plus root of 100, which is 10, over negative 6. And x2 is negative 8 minus root of 100 over negative 6. Let's do some mental math here. Negative 8 plus 10 that's 2. 2 divided by negative 6 is negative 0.33, right? It's a third. Negative 8 minus 10, that's negative 18. Divided by negative 6, that's positive 3. So it checks out. Checks out. Okay, so this would be a bonus, so we don't count that for the back. So 1, 2, 3, 4, 5, 6, 7, 8. So the back side is 8. And if you get a bonus, then just add it to whatever mark you got there. Okay, so 8 and 9, that's 17. Make sure your name and last name is on there. I will collect it and return it.